video, we're going to look at using an algebraic representation to explain the effects of a given positive rational scale factor applied to two-dimensional figures on a coordinate plane with the origin as the center of dilation. So basically, we're going to use the rules to see if the dilation has worked, or that the rule represents what actually happened on the graph. So first off, when we look at these algebraic representations, these rules here, we don't want to be fooled by them. When we think scale factor, we want to think multiplication. In this case, we're adding 15 and we're adding 5 to the different coordinates of these original points. So those are translations. That would be to the right 15 units and up 5 units. This one would be moving left 15 and down 15. So these are not dilations. So don't be fooled by these rules that have addition and subtraction in them. What we do want to pay attention to are rules that have multiplication. These representations will create a dilation. Scale factor, think multiplication. So here we have the original xy, and we're going to multiply the original by 2/7, both the x and y coordinate. xy multiplying by 7/2 on both the x and y coordinates. So when our scale factor, or the number we're multiplying our x and y by, is less than 1, so 2/7 is less than 1, we're going to have a reduction. If it's greater than 1, like this one, so our numerator is larger than our denominator, so we have whole numbers here, we're going to have an enlargement. When that scale factor is greater than 1, we get that enlargement. Let's take a look at a problem. Polygon LMNPQR is shown on the coordinate grid and models the shape of a garden in a park. Polygon LMNPQR will be dilated with the origin as the center of dilation to create polygon L', M', N', P', Q', R'. The vertex of M' will be located at the point 1535. Which rule best represents the dilation? So we need to choose the correct rule that we see here. Our starting point of M is at 614. I know that because if I go over to 6 and up to 14, I find my point M. So that coordinate is 614. So I'm going to apply these rules to see if I end up with the point 1535 after I apply the rule. So let's look at A. I see that I have multiplication here, 2/5 times x, 2/5 times y. So let's test it out. 6 times 2/5, we multiply 6 times 2 is 12 over 5. So we get 2 and 2/5. That does not match my x-coordinate of my M' point. Let's try the y just to make sure we didn't make a careless mistake. 14 times 2 is 28 over 5, and that's going to give us 5 and 3/5. Once again, that y-coordinate does not match. So this is not one of our answers. Then looking at B, I see that my xy, I'm adding 9 and adding 9 to my x and y coordinates. Remember we talked about addition. When you're adding, that is a translation. So this is not a dilation. When I look at C, I see I've got -9 and -9. Once again, not multiplication, so that is also a translation. So this is not an option for this problem, which leaves us with answer choice D. Well, we still want to check it. So once again, we start with M is 614. So we're going to take 6 and multiply by 5/2. So 6 times 5/2 is 30 over 2, which gives me 15. And so far so good, that x-coordinate was supposed to be 15. And then for my y-coordinate, 14 times 5/2, 70 divided by 2 is equal to 35. So my y-coordinate matches up as 35. So answer choice D is the correct answer choice to represent this dilation.